Okay, so in the previous video, we talked a little bit about what an orbital diagram is, what we can learn from it, that kind of deal. So now we're going to talk about how you actually write them. So we'll get to know a little bit more about them in the process of having to write them out yourself. So that being said, first things first, when you're writing an orbital diagram, you need to determine how many electrons you have. So remember, as we're doing these orbital diagrams, we're always talking about a neutral atom. We're always talking about a neutral atom unless we specify that it's an ion, right? That's why we have special notation for that. Anyways, but we are talking about the fact that we have a neutral atom, so therefore the number of protons and electrons are equal. So we can just use that number or atomic number on the periodic table. That'll also tell us our number of electrons for our purposes in making an orbital diagram. So first and foremost, you have to determine that number of electrons. Second and foremost, you need to determine the number and type of orbitals you have. When I do this, I tend to use the periodic table to guide me. So I'll think about, is it in the S block? Is it in the P block? Is it in the D block? And then I'll think just a little bit more about where it's located up and down, right? The hydrogen and helium are that principal quantum number 1. Then the second row is the quantum number 2, principal quantum number 2. The third row is the principal quantum number 3. The fourth row is P and S are 4 and D is 3. And then the fifth row is the 5s, 5p orbitals, and then the 4d orbital is in the middle there. So you got to determine the number and type of orbitals you have. Again, we're going to use that location on the periodic table to help us determine that. Once we know what type of orbitals we have, we'll draw out all the boxes that we're going to put our electrons in. So be sure you group the orbitals together. You got to group all of the p orbitals together, group all of the d orbitals together, because remember there is an s orbital, 3 p orbitals, and 5 d orbitals underneath kind of each subshell there. Every time you write that out, you make sure you group those together and you label them with both their letter and their, that should say number, letter and number below them. So if you have the 1s orbital, you're going to write 1s below. If you have the 4d orbital, you're going to write 4d below it as well. And we always write them in order of increasing energy. So you'll start to see that I tend to write my orbital diagrams such that lowest energy at the bottom, highest energy at the top. So it's kind of like lowest to highest, bottom to top. And then from there, you have to fill your electrons into the orbitals. So each orbital can hold up to 2 electrons, opposite spin. And when filling the p and d orbitals, you fill each box with 1 electron, and you only pair electrons if you absolutely have to. You make sure, again, that you're denoting that spin up and spin down in that case. So let's do a couple of examples so I can really show you what I'm talking about. So I conveniently have put a periodic table here on the chart for you. The periodic table you get on your exam will be similar to this one, just without the colors. So keep that in mind. So let me scooch myself over just a little bit here. Whoop. Okay, so let's draw some orbital diagrams. So, example number 1 wants us to draw the orbital diagram for beryllium. So beryllium on your periodic table is right here. It is number 4. So beryllium is number 4. I'm going to go ahead and make a note of that. We're working with beryllium, and beryllium is number 4 on the periodic table. So first things first, I need to decide how many electrons beryllium should have. Well, charged neutral atom, same number of protons, same number of electrons, 4 protons, so I'm going to have 4 electrons. Okay, so beryllium will have 4 electrons, and then from there, I'm going to look at where it's located on the periodic table to determine how many and what type of orbitals it will have. So hydrogen here and helium, these two form the first row, and they are the 1s orbital. and then we'll have the 2s orbital. So this lies in the s block, and it's the second row. So beryllium is the 2s, will be its highest orbital, highest energy orbital. So it'll be the 2s orbital, okay? So now that I know my number of electrons and I know what my highest energy orbital is going to be, I'm going to go ahead and start to draw my diagram. Oop. So we'll do, woof. There we go. So we'll go ahead, we will draw it so that the lowest energy is at the bottom, highest energy is at the top. And so our lowest energy orbital is going to be the 1s orbital, and then we'll go all the way up to the 2s orbital, okay? So now that we know how many electrons, we've determined our highest energy orbital, and we've drawn all those boxes out and made sure we labeled them, we are going to now put our electrons into the orbital. So I have 4 electrons I need to put in. So I'll start with that lowest energy orbital. We're always, always, always starting with the lowest energy orbital. So I'll put 1 spin up electron into the 1s orbital. Then I will put a second electron into the 1s orbital. So now the 1s orbital is full. We need to move on to continue to add electrons to our diagram. So here we have the 2s orbital. I'm going to put 1 electron in, spin up, and then I'm going to put the second electron in, spin down. So now my diagram has 4 total electrons, and I started with the lowest energy, worked my way up to the highest energy there, and I put them in, only forcing them into pairs because I absolutely had to. So this is the orbital diagram for beryllium that you see here on your screen now. All right, so let's go ahead and do another example. So let's do sulfur. So sulfur's over here. It's number 16 on the periodic table. So we're going to be working with sulfur. Sulfur is number 16. So again, charged neutral atom, same number of protons as electrons. So therefore, I have 16 electrons. And then I need to determine where on the periodic table this lies so that I can determine the orbitals that it will contain. So sulfur is very clearly over there on the right-hand side in the p block elements. And it's in the 3rd row, so that means my highest energy orbital will be the 3p orbital. Okay? So let's go ahead and draw that orbital diagram now that we kind of have all our base information. As always, we're going to draw our diagram with lowest energy at the bottom, highest energy at the top, and I have to get all the way up to the 3p orbital. So I'll draw the 1s, then we'll have the 2s, and then we're going to go ahead and put the 2p block just next to the 2s. And while we know that they actually have different energies, you'll kind of start to see here, I'm going to draw my orbital diagrams so that they kind of mirror an upside down periodic table. So the periodic table kind of goes like 1s, 2s, 2p, 3s, 3p. We're going to go from the bottom. We're going to go 1s, 2s, 2p, 3s, 3p, so on and so forth. So let's go ahead and put the 3s orbital and the 3p orbital. So now that we know how many electrons we have, we know that we have the 3p orbital as our highest energy. We drew all of our orbitals up until that point. We can go ahead and start putting our electrons in. So just like before, we'll put spin up and spin down in orbital 1, the 1s orbital. We'll do spin up and spin down for the 2s orbital. And then as we fill the p orbital, remember, we only pair them up if we absolutely have to, okay? So 1, spin up, spin up, spin up. Looks like I have to pair them, so we'll do spin down, spin down, spin down. Now that 2p orbital is full. So you're filling all the orbitals from lowest energy to highest energy, and you're going to make sure you only pair the electrons up if you absolutely have to. So we've got a spin up in the 3s, a spin down in the 3s, and now we're left with 4 electrons we need to put into our diagram. So if we have 4 electrons we need to put into our diagram, they're going to go into that 3p orbital, and remember, we only pair them if we absolutely have to. So that's going to look like spin up, spin up, spin up. Then the next one will be spin down. Okay? So this is the orbital diagram for sulfur. Okay? Pretty neat. Now, let's keep chugging along, and we'll go ahead and do the orbital diagram for bromine. So bromine is right here. Bromine is number 35. Okay, so bromine is number 35. So we know that that means we have 35 electrons, charged neutral atom, 35 protons, 35 electrons. And then I need to figure out what the highest energy orbital is for bromine. So bromine sits in the p block, so we know it's going to be a p orbital, and it's in the 4th row. So the 4th row for p. Okay? So now that we know the number of electrons we have, now we know the number of electrons we have, and we know the highest energy orbital we'll be using, we can go ahead and start to fill from the bottom our number of orbitals up to the 4p. So we have the 1s orbital, we have the 2s orbital, we have the 2p orbital, we have the 3s orbital, we have 3p, then we have the 4s orbital, but remember that 3d block sits in the center, so we're going to go ahead and call that 3d here. Remember, the 3rd row starts with d, so d starts with 3 is how I remember it, and that's going to have 5 boxes because the d orbital has 5 orbitals in it. So I'm going to go ahead and draw 5 boxes. It has more energy than the 4s, but the 4p is the highest energy orbital we'll be dealing with. And so this is why I kind of like to write them out like this. So it's important that you kind of follow this almost upside down periodic table structure, because it helps you remember that that d orbital actually sits in between the 4s and the 4p. So what can be really confusing about these is remembering that that 3d orbital sits in the middle between the 4s and the 4p. Even though that principal quantum number is less, it actually has more energy than that 4s orbital. So by doing it this way, you're kind of mimicking what you see on the periodic table, and that order you can follow on the periodic table is actually how we would fill these orbitals. So let's go ahead and do that. So we start from the bottom, we work our way up to the top, and then we start at the bottom, we work our way up to the top, we fill every orbital until we get to the end, and we got to stick the last few electrons in. Excuse me. So let's do it. Spin up, 1s, spin down, 1s, spin up, 2s, spin down, 2s, spin up, spin up, spin up, spin down, spin down, spin down, 2p, 3s, spin up, spin down, 3p, spin up, spin up, spin up, spin down, spin down, spin down, 4s, spin up, spin down, 3d, up, 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 down, 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 down. And so now we're left with 5 electrons. So we have 5 electrons left, and we need to put them into our orbital diagram. And remember that you do not pair those electrons up until you absolutely have to. So this is going to look like spin up, spin up, spin up, spin down, spin down. Okay? So that there is the orbital diagram for bromine. It's important that you guys start to learn how to write these orbital diagrams. They help us to understand where the electrons are in an atom so that we can better, again, we'll talk next time in part 3 of chapter 9, I should say. It'll help us to understand a little bit about the chemistry they participate in. So, as always, you can see these examples written out in a much prettier manner here. Beryllium, sulfur, and bromine. And so I also gave you some practice atoms here if you want to practice drawing those orbital diagrams. So, a really, really good question for an exam would be something like this. If I gave you an orbital diagram, could you identify what element it belongs to? Or if I gave you an element and I gave you a bunch of random orbital diagrams, could you match that element up to the proper orbital diagram? Okay? So, for the first one here, the way that I always complete these problems is to look at that highest energy orbital. So we know that like if I'm like even looking at the 2p orbital, that everything underneath it is going to be full. So what you can do is then look at which orbital isn't full, and that will help us to determine what element we have. So here we have the 2p orbital, so that means I'm going to be looking in the p block, and I'm going to be looking in the second row, okay? And then I have 4 electrons in it. So what I do is I go back to that periodic table, I start to look at the 2p row, which is this row right here, and I figure out which one has 4 electrons in it. So that would be 1, 2, 3, 4 electrons. This row would have 1 electron in the p block, this one would have 2, this one would have 3, this one would have 4, 5, and 6 as well. So oxygen has 4 electrons in the 2p block. So therefore, that picture we see, that orbital diagram, is oxygen. So let's get some practice and let's do the next one on your screen as well. So I see that the highest energy orbital I have is 3p, and it's 3p with 6 electrons in it. So let's go find which element is 3p and has 6 electrons. So row 1, row 2, row 3. I'm going to zone in on this area. So this would be the 3p block. And then I'm going to look and I'm going to determine which one has 6 electrons. This one has 1, this one has 2, this one has 3, this one has 4, this one has 5, and this one has 6. So that element is going to be 3p with 6 electrons. That is argon. So we found that this is argon. So we have oxygen and we have argon. Let's do 2 more quick examples here, and then we'll kind of wrap up what we're talking about with orbital diagrams. So here, our highest energy orbital is 4s. So I'm going to go seek out that 4s orbital, and I'm going to look for the 4s element that has 2 electrons. So let's go find it. There it is. Oh, sorry. Sorry for all the flipping back and forth. I just have to keep finding a periodic table. So again, we have the 1s block up here. Here's 2, here's 3, here is 4s. So s block, 4s is right here. 4s is potassium and calcium. We got to figure out which one has 2 electrons. Well, potassium has 1, calcium has 2. So it's kind of like within the block, you're counting the electrons within the block itself. So the s orbital can hold up to 2. The p orbital can hold up to 6. The d orbital can hold up to 10, right? So if my, so you're not really like counting the overall like electrons or anything like that. You're just counting within that block. So if I'm looking for 4s and it has 2 electrons, 1, 2, it's going to be calcium. So that orbital diagram we see is for calcium here. This is calcium, Neat. Strong bones. So let's do the last one you see on your screen. Let me move my big old head out the way here, and let's check it out. Oh. So again, you look for that highest energy orbital. So that's going to be the 5p orbital, okay? And then from there, we are going to count the number of electrons in it. So 5p. So here is, let me move my big old melon out the way again. So again, here is 1s. Here is row 2, so 2s, 2p. Row 3, 3s, 3p. Row 4, 4s, 3d, 4p. 5s is next. Yeah, 5s is next. And then we have 4d. Then we have 5p. And we want to know which one has 2 electrons. So we count from the left over to the right. 1 electron, 2 electrons. So that element of that orbital diagram will be tin. So that's tin. Sn is tin. Kind of doesn't make sense in a way, but Sn is tin. So those 2 orbital diagrams you see there are calcium and tin. So you should kind of be able to freely go back and forth. Can I look at the orbital diagram and determine the element? If I am given an element, can I either identify or actually draw that orbital diagram myself? So that's kind of what we want to talk about here with orbital diagrams. You can kind of start to take some time to summarize in your notes about them. They are a way for us to see how electrons actually fill orbitals. And you fill from the lowest energy orbital up to that highest energy orbital, and it kind of goes in a rhythm of 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p. Breath. So you'll start to fall into that rhythm. You'll start to you'll hear me all the time, 1s, 2s, 2p, 3s, 3p, so on and so forth. And remember, it's kind of like an upside down periodic table. When we go ahead and we put those electrons into the orbital diagram itself, what's going to happen is we fill the orbitals completely as much as we can with their maximum number of electrons until we run out of electrons. And so you fill them spin up, spin down, and you always leave them unpaired until you absolutely, absolutely, absolutely have to pair them up. Okay? So that's what I kind of want you to get to know and learn about orbital diagrams. Up next, we're going to talk a little bit about electron configurations. Ooh.